over today is the sine and cosine graphs and how these might be applied in the syllabus. First thing I'd type into Google is this, and then I'd click on to the sine function degrees Desmos. This means that the function looks correct. Now what I would then do is get rid of all these sliders, and later on we will talk about the sliders, and just change this function to y equals sine x. That's all you need to do. So the first thing we're going to discuss is what kind of function this is. A sine and cosine function is a periodic function. What we mean by that is that it repeats after a certain pattern. So once we go up to its maximum and then we go down to a minimum, this pattern is just then repeated for an infinite number of times. You see this pattern a lot in natural life and in things like physics experiments. Now there are two key things we need to talk about in this course. First of all is the period length. Now the period, when it comes to sine and cosine graphs, is to do with how much degrees it takes for it to repeat. So if we start the process here, it goes up to the maximum, down back to the original x value or y value because it's returned back to y being 0, then down to the minimum where y is now -1, and then back to the original y value of 0. That is called the period. And the period, half a period is 180 and a full period is 360. This axis is in degrees. You do not need to study this in radians. Now in terms of something else we need to study, it's called the amplitude. Now the amplitude is the maximum distance between the axes in this instance and its local maximum or minimum. So if we go from the axes, the y value is 0, and if we go up to the maximum value, it is 1. So the amplitude is 1. Those are the two key factors you need to know. Later on in the course, we will be transforming these graphs. So if we then add in a different graph, cos of x, what do you think is different about the sine graph and the cos graph? Pause the video. Welcome back. Hopefully you notice that this graph has been shifted. So instead of starting at 0, 0, it now starts at 0, 1. Now we can use these graphs to answer questions, and we're going to go straight on to the questions, but we will talk about the graphs later on in the course. The first question we're going to talk about is the following. Given that the radius of a Ferris wheel is 70 metres and that the angle represents the angle measured anti-clockwise from the x-axis, find all the angles for which the pod is a distance of 40 metres vertically above the x-axis. Now this sounds pretty complicated. If you're talking about Ferris wheels, this is very typically sine or cosine. And the reason why is because this is to do with the motion of the Ferris wheel. So we're going to get into the intricacies of the problem later. The first thing you need to do is to be able to draw a picture. It says the radius of the Ferris wheel is 70 metres. So we draw this to be 70. The angle, we draw that into the triangle, and the vertical distance is 40, which we draw here. The first step of these problems is to decide whether you're using sine or cosine. So, in this particular problem, we need to label the missing side. So we need to label all the sides as opposite, hypotenuse and adjacent. This is the opposite, this is the hypotenuse, and this is the adjacent. So once we've labelled the missing side as adjacent, we know the problem is not about the adjacent, it's about the two sides we're given. It's about the opposite and the hypotenuse. And using SOHCAHTOA, we know problems to do with opposite and hypotenuse are to do with the sine. So what you would do is you would create the sine graph using your calculator. We are going to write sine of x. Now let's have a look where we'd find this. Here's sine. So let's press clear and we're going to select sine of x, close brackets. And then we're going to put graph. Now you can see we cannot see much of the window. So we need to first of all check it's in degrees. Now during the whole course we are working in degrees, so please don't change this, but if you've got a new calculator you might want to change it. It's in degrees. Now for the window, what you're going to do is your x min and your x max is going to be to do with your x-axis. So going back to Desmos, we could see that one whole period would be covered in 360. But maybe we would like to see a little bit more and a little bit less. So let's go from, say, minus 50 to 400. That will give us a little bit more than the whole period. So as I was suggesting, minus 50. Now make sure you're using the small minus, not the big minus, because we're dealing with a number which is not in an equation. And let's change this to 400. So the y, of course, as we were looking here, the y is the amplitude. The amplitude varies between 1 and minus 1. So the amplitude is 1 because the difference between this x-axis and the max or the min is just 1. So here we go, we're going to write down, let's make it a little bit smaller, minus 1.1, and let's go for 1.1. Let's see if the graph is looking a little bit better. Fantastic. We can see the periods occurred. We can see the amplitude here. So what's the problem actually asking us? A distance of 40 metres vertically above the x-axis. So effectively, what we're saying is that we want sine of theta to equal opposite over hypotenuse. If we simplified this, we would be saying sine of theta is the same as 4 over 7. I am going to plot a straight line. And I would like to find out when we have got 4 over 7. And let's see what that looks like now. 4 divided by 7 graph. Actually mean? Please watch this video and I'll explain how this Ferris wheel is turning into a sine curve. So the sine curve being created is this red curve here. And it's being created based on a capsule in a Ferris wheel in a fairground ride, moving all the way round back to its original position. And now we're going to go backwards. Now I'm going to explain something really important. The first thing I need to explain is that the x-axis, as discussed, represents the angle. This represents the angle here in the centre of the image. Now what's slightly confusing about this image is that it goes up to 6. Now this is because it's measured in radians rather than degrees. Let's imagine instead we're going to measure this in degrees. We're going to say the first half of the period is going to be completed at 180 degrees. And then it's finally completed in full at 360. So for now, ignore these little numbers. You will not need to do this unless you do maths at a higher level. Now, this particular value here on the x-axis is going to be represented, say, by about 160. And the reason why is because in this diagram, if we go from the beginning line and we're going anti-clockwise, this capsule, which has started on the Ferris wheel, would have travelled about 160 degrees to get to this point here. Now, the other important thing is the y-axis. Now, the y-axis is going to tell you relatively how high the capsule is going to be. So at this point in the video, we have the vertical height to be quite small, which is why this corresponding y value, which is going to be here, is going to be quite small. What I mean by that is that the maximum amplitude is 1, which is here. And we've got a value which is less than 1/2. And this is because the height of the capsule from the x-axis is quite low down at this point. So let's watch this video again. We're starting off with quite a low height and a small angle. This is representative of a small x, small y. We're getting increasingly bigger in terms of our height. Our vertical height is almost at its maximum. Therefore, our curve is almost at its maximum amplitude. Then when it reaches its absolute maximum, we have a maximum which occurs in the sine graph. The angle at this point is going to be 1/4 of a cycle. The whole cycle is going to be 360 degrees. Please re-watch this video and ask me questions if it's still not making sense. So the question itself we're actually doing is saying that it needs to be 40 metres vertically above the x-axis. So if we were to form an equation, we're going to get sine of the unknown angle is 40 metres, which is the opposite, divided by the hypotenuse, which is 70. So if we look at this function, we're going to say sine of x is equal to y. This is the y-axis, 40/70, or 4/7. So in order to solve this equation, all we need to do is label the triangle, which we've done, decide whether it's sine or cosine, which we've done. Then you plot the correct graph, which we have done with the sine x. And the last step is to get this relationship as a fraction. So this has got to be opposite over hypotenuse. Obviously, cos is going to be adjacent over hypotenuse. And then put that as a separate line and just see where they intersect. So once we put graph, we can see that they intersect at 2 points in the period of 360. So what you need to do is just see where they intersect. So you need to press second calc, number 5 for intersect, and we are going to select the first curve, enter, the second curve, enter, and then where they intersect, so the actual crossover approximately, enter. There we go. They intersect when the angle is 34 degrees, and this generates a height of 0.571428. Now this y value is really important, and it's linked to the relationship between the 40 and the 70. Now the other place we've got to see where it intersects is this part of the sine graph. So we need to press the same process again, second calc, intersection number 5, first curve, which is the blue curve, second curve, which is the red curve, and then where they intersect. Here we go. 0.571 and the angle's 145. So we get two separate answers. Our separate answers are going to be 34.8 and 145 degrees. Now when we do this for the cosine graph, the answer is going to be a little bit different. The reason why is because we're going to answer it so that it's 20 metres horizontal difference. So this question here had 40 metres vertical. This question here is 20 metres horizontal. So labelling the triangle again, we are going to have the following. Opposite, hypotenuse, adjacent. This clearly is about the cos graph. So instead of doing sine, we are going to change our graph to cos. So we just need to write cos here instead of sine. And it's asking us for a relationship where we've got adjacent over hypotenuse 20 over 70. You could write 20 over 70, or you could just simplify it. 2 divided by 7. We're going to graph it. This time we have got the answer here. Now, this question is a little bit different because it's asking us 20 metres horizontally from the y-axis. And rather than saying horizontally above and below the y-axis, it's saying from the y-axis. So we want to have it above the y-axis. This distance is 2/7, but we also want it below the y-axis, so a distance of 2/7. We're going to go on to the y equals, and we're going to plot a negative 2/7 this time. If we click graph, there we go. We have got 4 intersection points. Now, actually, what you can do is find out the x without doing this intersection process. So if you're running out of time and you're not quite sure whether you've got time to complete this question, you can kind of guess these answers. We've got 4 intersection points. One at x is equal to 270. And that's not correct, that intersection point. Pause the video and think why. Excellent. That's not correct because that is on the y equals 0 line. We want to go above and below. So let's go above first of all. If we go above, again, I wouldn't recommend this if you want full marks. This is more if you're running out of time in the exam. And you can see it's a little bit fiddlier than what's expected. There we go. X is approximately 284. If we go to the other value, we are going to have x is equal to 76. And then we've got the 2 values below. We've got this value intersection on the bottom left. X is 108. And last but not least, we have got this one here. X is 253. Let's just check with the mark scheme. So we have 4 answers, 73.4, 287, we have 253 and 107. Be careful to round each of these to 3 significant figures. If you get the answer wrong, so say if I guessed this and I put 254 rather than 253, I would lose the mark. Luckily, this has rounded it correctly because my dot is quite accurate. But if I put it there, you can see how it's not that much different, but it's wrong. So please be careful and don't always use this guessing method. What I'd like you to have a go at now is these questions on the screen. I'm going to zoom in for you. So question 1 is very similar to what we've just done. Question 2 is to do with intersections of graphs. So for this one, you'd put y1 is sine, y2 is cos. This one would be y1 is cos, y2 is minus 0.1. So have a go at these.